Hello and welcome back. Today we've got a bit of a mixed bag of things. So first off, we've got a Mailbog, and these were kindly sent in by my friend and subscriber that we've been corresponding online. Long story. His name's Ian. Bless you, Ian. Thank you very much. He's kindly sent me some. Oh, I'm going to say Tektronix then, but it ain't Tektronix. Fluke. Some Fluke leads, and they look super duper. They're better than all the leads I've got, which are a motley collection. They look capable of dealing with quite some high voltage, so they very safe things, shrouded with some. These clips are just, oh yeah, them clips are just fantastic, because this is the sort of problem I encounter when I'm trying to take readings is getting your clips to stay on, but they can cover like sort of really tiny sort of stuff and big stuff too, so brilliant. And yeah, there's a few bits of doings in here. I've got 3 leads and 3 colour coded sort of probes. Oh, god blimey, they're sharp, just a job. Yep, and he's also popped in a couple of neon indicator switchy type switches. Brilliant, thank you very much, Ian. I'm well chuffed with them. I mean, these must be able to, what does it say there? I can't see, Friggle, what does it say? That's right, yeah, so 1000 volt, just a job, because we're always, now then, I took one apart earlier on, we're always mucking around with high voltage, and they've got a big fuse in. I mean, ain't they just Bobby Dazzlers? What's going off this frigging camera? Sorry, the camera's playing silly buggers again. Right, so, brilliant, that's them, so I shall definitely use them. And then, I was going to do a video, fault finding video on the Tektronix 545. Because I had a problem with the trace. I thought it might be the time base at first, no. And then I thought, that looks more like a vertical amplifier sort of business fault. The trace had like undulations like that. So I thought, right, great, that means we can do a really long fault finding, sort of general fault finding video on electronics. On the lines of, first, what is the fault? Describe it. Because, you know, if you're going to find the problem, you have to know what the hell it is that the fault is. You know, you've got to be specific. But what happened was, I got all my big box of valves out. All sort of, most of these are pentodes that came from Tektronix scopes. And I thought, right, well, you know, we'll try changing a few valves first, but there's also some transistors in there, so I got the trusty handy dandy what do you call it, transistor tester out, and the transistors on the Tektronix scope there, they come in little sockets, so you pull them out, test, pop them back in. I did that, they all tested okay, and then there was one valve I changed, and that's this one, which is a 6DJ8 ECC88, but it's a special one because it's tested within specific parameters. I've got another one, so I changed that, you know, unplugged those what do you call it, transistors, and it fixed the problem. So go figure. So instead what we'll do, I think we shall have a bit of a play with the Tektronix 545, because I learned how to do this yesterday. I learned how to get it to function in XY mode. So we're going to need 2 signal generators for this. We've got our, pop you up a bit, we've got our trusty HP8903B, which we'll use for 1, so we'll set that to, right, let's get that intensity down blah blah blah. What are we after? Right, frequency 1 kilohertz, amplitude 2 volts. So we've got that one. We'll have that one going in. We'll have that one going into the vertical, and that just gives us a line. Right, so that's our vertical line. Because we've got no sweep, it's not going anywhere. So that 1 kilohertz is just a line. So now we need to. We've got some. What would you call this? It's a function knob. So we set that ×1 external. This is our external horizontal input. Okie dokie. And here, if I move you over here, it's a bit hard to do it both at the same time. That's just moving that. That's moving the sort of horizontally bit. Right, and then now we need another one, which is another input. We've got an advance. Hold on, one moment. We've got an advance signal generator type 81A. Right. I had a lovely trace yesterday. And of course now the bugger's gone. Oops, sorry. Let me have a fiddle about with this a minute, and then I'll turn you back on. There we go. It was hiding round the corner, a swine. So as you can see, this sort of, well, it's like a circle just moving around. Now then, if I change the frequency on the, well, first let's try and get a bit better. So you see what that variable 1 to 10 horizontal thing does? Just makes it bigger, smaller. Right, and now if we change our setting on our vertical there, now then, see we've got a nice circle floating about in space. If we change the frequency a tad on the Advanced 81A, see we start getting some movement. If we get the both bang on 1 kilohertz, which is very tricky to do with any generator really. We can slow it down. There we go. That's probably about the best we're going to get it. It's never going to be a proper circle because the frequency drift, mainly of the Advance 81A, which is which uses valves. So you know, it's got to warm up. And obviously, if we now change the frequency, we get all sorts of craziness going on. Alright, so now we are putting in about 70 Hertz from the Advance. Can I get it to settle? What happens if we bung it right up? Well, we just get, yeah, that's too much. We want low frequency. So you get the idea. Now then, while we're at it, I don't know if some of you will have seen this chap. He's a bloke called Jeremy Anderson, maybe. He's done some great work where he's got mushrooms dancing and all that. So, shall we give that a try? Right, I've got to go and reel out a big bloody reeler cable to bung it into my amplifier in the other room. One moment. Right, here we go. Right, I'll go and start it from the beginning. And while that's playing, unfortunately I can't play music at the same time because if I plug it into, I'm plugged into my amplifier headphone socket, which of course mutes the output. I'll tell you his name in a minute. I'll tell you the chap's name. But he did all this using a Linux program. obviously very mathematical and yeah, clever chap. Oscilloscope music, eh? I think he did a where do you call it, album as well. Yeah, well, I think we've watched about enough of that. Also, I did a bit more, I've got some footage of the preamplifier build update, which I'll tag on to the end of this. Obviously today on the bench we've got the chassis for the preamp. Haven't made much progress. The fettling, or the what do you call it, engineering of the metalwork has been problematic. This build is being done on a really tight budget, meaning that I've got to try and use what bits I've got, like this, my gubbins here. So as you can see, it's well, we've got 12 RCA phono connectors. I was originally going to use that. The problem is, I'm going to try not to touch this too much because I've just painted it. Problem is trying to mount it in the back there. So I'm trying to do it in such a way that it looks good. So this was the original plan. Bang that there, you get the idea. And then, but that's no good. I mean, that just looks shite, doesn't it? So I came up with a cunning plan of using a plate, putting a small plate on like that, which would just about work. Oh, there me. I didn't want to do this, I didn't want to touch that because I'm going to put another coat of paint on it, something like that. But as you can see, the holes aren't quite, well, the holes aren't accurate. This is a problem I struggle with with the sort of workshop facilities that I've got, is drilling holes accurately. You can probably drill one or two holes reasonably accurately, but when it comes to many holes, we're buggered. I couldn't cut it to size, and you see I've got like a marking there, and then cut the holes, because I knew there would be some shift, and there was. So that was attempt 1. Attempt 2, I mean this is all bent and everything, but it can be straightened out. Attempt 2 that was, and then I cut the bloody thing too short. And this was attempt 3. So okay, we're getting there. So that, you see the idea, do that, mount it, score, you know, mark it out, and then cut it. But the problem we've got with a preamp, because you amplifying small signals, you've really got to watch your grounds, and you don't want all your grounds. You see this metal plate, this metal conducts electricity, right? This is all a ground, so it would have been grounded sort of here and here. We don't want that. And the other thing is, it's not the best, is it? A kind chap on forum came to my rescue and sold me some individual little RCA thingy doodahs, but that's yellow. We don't want yellow. We want black and red. Where's me red ones? We've got a few reds, but not enough. So what I did, I found that I could paint some of these black ones or some of the yellow ones with red nail varnish, and that works out okay. So we're good there. So scrap that. Version 2. See, all this takes time. All this mucking about takes time and doesn't get the job done. I mean, the valves are still sitting in the boxes. So that's what we're going to do now. So this was the original plate that came on the device. This is better because we've got our RCAs further mounted apart. Now each one of these has got to be labelled PC, auxiliary, radio, whatever. Gives us more space. So we've got 4 ins for four ins, a sort of tape out and an out. so that's a lot better. So drilled those, and again I marked them out really well and used a magnifying glass to centre punch or centre pop each position of the hole. But I noticed the bloody holes had moved a little bit, so they're not 100% accurate. However, we're okay there because the holes are a bit oversized, so when they go in, so they will move a little bit, and that's okay. As you can see on this one, I put a little bit of heat shrink. Again, we don't want that the ground into this plate. So we've got a bit of heat shrink, that should do, okie dokie. And then we've got to make sure that we've got plenty of paint on here so that this surface, so I get you in frame a bit better, doesn't you know, electrically connect to the plate. Same goes to the back. So it's, yeah, trying to do a job on the cheap, it's problematic. You can get sort of these sort of things with fibre washers, brilliant, because that sort of works, long as the inner bit don't touch the hole. And even better, you can get some that have got plastic, but I've got none of those. And so that's the back sorted out. So can't really get this done quickly. It's got a first layer of paint on it, and it's got to have what, another at least 2, and then it's got to be let dry for a week really before you can start working on it. So yeah, it's going to be delayed. I'm trying not to touch this too much, and then that's the front. So we'll basically have a switch and a volume. So our volume control will sit in there, and our switch will sit in there. So we'll have our ends here coming to our switch, from the switch to the volume, from the volume to our valves. So you have to think all this sort of stuff in advance, which, yeah, there's a lot to think about. You've got to think about the fabrication, that was the word I was looking for earlier on, the fabrication of the metal, because we've got some metal and we're adapting it. And we've also got to think about the grounds and all the rest of it, and the signal paths. So they go there, blah blah blah, in's there, out's there, and then yeah, we can get building. So this is a few days later now, and as you can see, the preamp is starting to shape up. Switch, volume control, and I've just popped a couple of connectors on the back there just to give you a rough idea. So once the paint's dried, we can crack on with the actual electronic and audio voodoo, which will be great to get into making some sine waves again and making some music, which is what it's all about. Thank you all very much for watching. Take care of yourselves, and ta-da for now.